Can you see my screen?
Yes.
Yes.
Yes, we can.
Thanks. So let's start. Today we're going to continue to study QGIS, and we're going to consider some basic tools to work with vector data. Jump to the full screen. The outline of this lecture is as follows. First of all, we are going to consider how to manage features of vector data, how to construct a query builder, and use joins tool. Then we're going to consider working with the attribute table, consider spatial and non-spatial tables in QGIS. Then we move to the vector overlays, clip, difference, intersection, union, and so on. Then we consider basic statistics for fields. Then we can count points inside polygons, and we consider how to measure the distance to the nearest hub and to perform the nearest neighbor analysis. After that, we are going to construct buffers. I see a question in the chat about a text part of a homework. It's okay if you have uploaded an archive with your picture and a text.
Excuse me, but there is no problem with reading these files. I mean, zip files. We can duplicate it to your email if it is necessary.
I haven't checked the zip files.
Well, LMS has a lot of jokes, you know. So
I think first I check this, and if something is wrong, I will let you know. Okay.
Excuse
okay,
me. And if I had put in my written part in comments about the project, is it okay?
I saw several messages in LMS. I think you're talking about this. I think you can find it in LMS if you send it.
Okay, thank you.
Thanks. So let's move on. Query builder. This is a dialog. This is a window, small window, where you can define which features you are going to show on the map. You can construct the SQL-like query exposed in the provider specific field filter expression box. And now let's run QGIS because I think it's better to run everything we're going to learn during the lecture. Let me stop sharing this window. I launch QGIS. I'm sharing my whole screen. Qgis is coming, I think. Yeah, it's here. Let's start a new project. I start a project with the world map. I just type world instead of coordinates. We can start from filter and this is a query builder. We can see that this layer contains countries. You can see all of them in here. I just choose name and then click all in order to retrieve all the records in the vector file. There is a hint. Then I can construct using this field, double click, name is equal to, for example, Russia, and a couple of neighboring countries. Name is equal to Russia, or name is equal to, for example, Finland, or, oh, sorry, equal sign is missing here. Name is equal to Finland, or name is equal to Estonia. Then I test this, test 3 rows, it's okay. And we can see 3 countries. And when I open the attribute table, I can see only 3 rows, 3 features in this layer. You can use this tool in order to, for example, change the view of a map, and then you can export this shapefile based on this query builder output. The next thing to manage features of vector data is Symbology. Now you know a lot about Symbology and labels, so I can skip this page and jump to the interesting thing about joins. This tab allows you to associate features of the current layer to features from an uploaded vector layer or table. Imagine that we have this world map. I remove this filter. I just clear up this small window. Then we have all the countries. Let's have a look at the attribute table. We have 240 countries, 240 features in this polygon map, in this polygon layer. We have data on names. We have data on some abbreviates, short names for each country. short names in FIPS, short names in ISO, and so on. And we have no data on, for example, country level indicators, for example, population density, and so on. We can find them, for example, using different sources like World Bank databases and so on. You can find World Bank database indicators, population density and population. There are pop density World Bank and total population from World Bank as well indicators.
Excuse me, where we can find those files in LMS?
Yes, in LMS.
Okay.
You can open materials, then lecture 3, working with vector data.
I see. And we need all of them, all 5.
Yeah, please download all 5 CSV files.
And which one do we need right now?
If you open, for example, total World Bank CSV file, you can see data on population starting from 1960, annual total population for each country. This is not a geo-referenced file, so this is just a table. It's a common spreadsheet with rows and columns and no geo-reference data, no coordinates in here. But we can add this source file to our shapefile. You can do like this. Just drag and drop these files to the layers window. Перетаскиваем файлы к слоям. Nothing happens because we do not use them as geographic layers. They are just tables. They are just non-spatial tables. Then we can open their attribute tables. Open attribute table. And we can see that there are data on country name, country code, indicator name, and population data. We want to use this data for this map. So we can join the layer with data from spreadsheets. We open properties of the layer, then go to joins, and create a new join. Add new join, plus sign, click. Join layer. Let's start from population density. Join layer. This table. Join field. There are different indicators. We need to check whether we have the same indicator. So let's go back. Cancel. World map. It's open. Its attribute table has different fields for short names. FIPS, ISO, World Bank, and so on. And the full name of a country. So we can check whether these fields are present. Country code. This is ISO-free country code. So we should use country code from this file and ISO from this file. Again, go to Properties, Joins, click Add a new join, join layer, join field country code, target field ISO A3,
And what is target field? So
target the same codes from the shapefile. We need to indicate two columns. The first column from the text table, from the non-spatial table, and the second field is from the shapefile. Указываем столбцы из первой таблицы и из второй таблицы, где содержатся одинаковые коды для стран, чтобы соединить таблицы. Then we can leave everything as it is recommended here. Then click OK. Then we go to the attribute table of the layer. And we see that there are additional columns containing data on population density. Each new column comes from the pop density table, starts from pop density World Bank. This can be fixed like this. Joint fields, all custom field name prefix, and we can edit, select a join. We can click a tick here, and we just remove this prefix. Remove the field name prefix. Okay. Then apply. Okay. Then check the attribute table. And now we don't have that prefix. We just have the original names of indicators, population density, POP-D, for each year. What is important? We don't have this layer in the original shapefile because we agreed that these data are in virtual memory. In order to save the data on population density for each country, we need to save the whole shapefile. Let's do it. World map, export, save features as SV shapefile, and we can click and choose geodata, world map, population density. Save. We see that all the fields with population density come together with the shapefile. Okay. So this is a new layer. I switch off the previous layer and let's check properties. There is nothing in joins section because this file, this layer, contains all the data, including population data, in attribute table without any virtual layer, virtual data. So you can add more fields in your shapefile using joins tool. And now we can just color the map using population density data. For example, Symbology, graduated value, for example. Oh, sorry. We need to check these fields. We have only one field with numbers, properties. Только одно числовое поле, только один числовой столбец. Проверяем. Attribute table. Open attribute table. All these columns are saved as strings. You can see that the column is a string type. So in order to fix this, we can add a new column with edited indicators. Let's go back to the slides. Now we can find.
May I ask a question?
Sure.
Why we need so many what is useful part of this moving? How we can do on the map all years of population? We have many years, but we have only one map. How we can use this data for our map?
Do you mean coloring?
I don't really understand how we can use so many years only on one map.
If you're talking about coloring the map based on population density, yes, you can use only one column for this. But this was an example how to merge data from two different files. The source file was a shape file, and the additional file was the CSV data files on tables. You can switch off or you can remove these fields if you don't want to add them. For example, when you save the file called map, you can export, save features as. If you don't need all the data, you can just switch them off. Select all, or just add, for example, the last available year for the last two of them.
And all those actions doesn't actually delete the values, so we just hide them. Am I right? Filtering and
we're saving as a new shape file. So from the original world map layer, you don't remove these fields. We just create a new shape file, world map population density 2020. Here it is. Open attribute table. And now we have only one indicator on population density for 2020. The next thing we're going to study is how to edit attribute values. For example, in this, let's get this. For example, we can see that we cannot use for this, for example, graduated symbology, our data on population density in 2020, because this field is a string field. So we need to fix this. We can add a new field. We start the editing mode, or we can then open field calculator, click this button, open field calculator. There is a tick for create a new field, output field name. Let's call this pop dance 2020. We may have limits, so we just rename this, for example, like this. Then we need to define an expression to fix this. This error, when we see a numerical value as a string value, is about types of fields. So let's have a look at different functions to use for fields. Нам сейчас нужно применить функцию, которая преобразовывает тип поля, поскольку у нас указано в нынешнем состоянии в таблице атрибутов population density указано как строковая переменная, нам нужно преобразовать это в число. There are different functions to transform fields in the attribute table, date and time, fields and values, general, geometry, layers, operators, and so on. For string values and so on. We need to transform from string value to integer. So this is toString. We need another function, reversed function. So let's try to find in this group, or to int conversions. This function converts a string to integer number. Nothing is returned if a value cannot be converted to integer or to real. So let's use to int, double click to int. Then we need to find the pop density field, double click, parentheses, and let's apply this, for example, for the first row. The expression is not valid. Just check.
Maybe we need to try toReal function.
Yeah. Probably it's the better solution because we can probably the field contains point zeros or some things like this. It's a more safe solution. And now this works. Real. What is weird? I don't understand this number as a conversion result. Let's check this. I click OK, and then here we can see the population density values as integers because the field type was integer. We can do it once again. Open field calculator.
Excuse me. And in field calculator, inside the function to real, what should we put? So the column or what?
Let's do it again. Create a new field because we have only integer values. We need to choose decimal number. Output field name. Population density. Let's call this decimal number, output field length, precision 3 digits after the point, after the decimal point, to real OPD 2020.
And what is POPD 2020? That was the question.
Population density for 2020. Number of people per square kilometer. This field is a string field. We need to convert this to a decimal number field. Then we click OK.
Okay, so it was a column.
Yeah.
Okay.
This column is a string column, and we cannot use these values for coloring our map. The last column is a real column, type double, and we can use it to color the map. This column, there's no need in this column. So we can either hide this or just delete this. There is a delete field button in here. So delete field, this one. Okay. Also, now we can delete this column as well, because we cannot use this data as string data, so we can delete field. Okay. You cannot restore the deleted columns, so please be careful. Then we exit from the editing mode. Выходим из режима редактирования. Нажимаем на карандаш. Do you want to save the changes to layer? Yes, I do. Save. And these changes are saved to the shapefile. So this editing mode for the attribute table, after editing and saving, saves the results to your disk, to your shapefile. Now let's color the map. Properties, Symbology, graduated, and here we have that field with population density data. Let's choose several classes, then we classify. We can have a look at its histogram. We can see that many countries with low level of population density. Then we apply this. Okay. And countries with high population densities are in red. With low level of population density are light countries. And now you can edit tables, both spatial and non-spatial, and you can apply different functions to fields. Also, it's possible to use attribute table. It's possible to edit attribute values using Python included in QGIS. For example, if you want to, based on the previous layer, compute the population growth rates or population density growth rates, you can use not one value, but not one field, but two of them. For example, let's jump to this map with different years. For example, we can use data on data on 2 last years, and we can create a new field. For example, growth rates. Expression. You can just use simple arithmetic operators. For example, like this, and then check whether everything is okay. This doesn't work because probably they're string values. So you need to use two real, like this, two real as well for the second column. And then check.
It's POP-G, name of column.
Yeah, exactly. Thanks. POP-D. Nothing for Antarctica. It's obvious. For Romania, for Australia, and so on. So you can apply different functions to compute a new field for your attribute table.
We are trying to compute ratio
Yeah.
Okay, thank you.
And you can, if you need them in, if you need a percentage of them, you can multiply it by 100, then you need to change the field type decimal number and so on. That's all about the field calculator. You can use different values, different columns. You can preview the result and so on. Let's move to the Python console overview. I'm not going to show using Python console during this course, but if you are interested in this and you know Python from different courses, for example, you can you can study this based on tutorials. There are links, but I'm not sure that I can wait for this, because when I use my Zoom, the internet connection, oops, sorry. Let me check this one. So the second link works. Here you can find basic things for Python within QGIS. So you can manipulate with layers, you can use different plugins, you can use different functions, operators to perform reproducible analysis in QGIS using Python. The next thing which is important for us is vector overlay tool. We're going to consider clip, difference, intersection, union, points within line intersections, split with lines, and so on, using QGIS. Clip, the first tool to learn, is this tool is usually used for polygons. We have two polygons, this one, the orange one, and the green one. The clip tool means the following: only the parts of the features in the input layer that fall within the polygons of the second layer will be added to the resulting layer. So the resulting layer are these two parts containing in the both layers. You can find them in geoprocessing tools here. Clip, a buffer, convex difference, and so on. So we cannot use this this instrument right now because we have only one polygon layer. By the way, the free layers world map, PopDance 2020, and just world map actually have the same features, the same shapes. So it will be useless to consider interaction, to consider clipping them. So let's consider the next tool, difference. This tool extracts features from the input layer that don't fall within the boundaries of our layer. The first layer, the orange one, and the second is green one. The difference is this part. Also, it's possible to extract features which fall within a specific extent. If you need to find all the settlements within a given region, within a given territory, it's better to use this tool. Intersection is this used for polygons layer, and the intersection operation is for this case is the same as for clip. Line intersection. This creates point features where the lines from the two layers intersect. Points of intersection for the red lines and for the blue line are 2 points, black. Also, it's possible to split the lines or polygons in one layer, using the lines in another layer to define the breaking points. You know that when we consider polylines or lines, we need to know about vertices, for example, point, and we don't have any points between them. But when we intersect this, when we split this line with another line, we can get the coordinate of a point between the two points. Найти промежуточные точки с помощью разделения, с помощью других линий, других слоев. Also, it's possible to define the symmetrical difference using QGIS tools. You know that the difference result depends on the order of layers. For example, difference between the first layer and the second layer is this part, and the difference between the second layer and the first layer is this part. And the symmetrical difference is both these results. Also, we can use the union tool to take all the parts of polygon layer, all the parts of two or more overlapping or non-overlapping layers, for example, polygons or lines or points. The next tool for analysis is basic statistics for fields. We can have a look at this tool using menu vector analysis tool. Let's jump to the QGIS vector analysis tool. This one, basic statistics for fields. We use, for example, population density data. We know that in this layer, PopDense 2020, we have at least one field which is not a string field. We fixed this, so we choose this one. Field to calculate statistics on pop density. Statistics optional. I will leave this field blank and then click Run. The result is in HTML file. We open this. And we have short.
Excuse me. What was the last action?
The last action was a click to this file path.
I see.
Yeah.
Okay.
Click this, and you see a short descriptive statistics for this field. То есть краткая дескриптивка для переменной pop_dn20. There are 2015 values. All of them are unique values. Missing values. There are 25 missing values, minimum value, maximum value, range, sum, and so on. So you can do simple descriptive statistics using QGIS. The next thing is to count points in Polygon. Let's do the example using data on settlements. You have settlements, Russian settlements. Let's add a new layer. Add layer from delimited text layer. File name. Settlements. Data. Longitude and latitude X and Y fields. Layer name. Settlements. Then I click Add. Then I close it. There are several misplaced coordinates. For example, this one. They are located outside the Russian territory. This one. And now we are going to count settlements inside Russia. Vector. Count points in Polygon. Vector analysis tools. Count points in Polygon.
Excuse me. Could you please one more time show how we edited this data? Sorry.
Okay. I remove this layer. Layer, add layer. Add delimited text layer. Or Ctrl-Shift-T. We're going to create a new layer from a text data. Ctrl-Shift-T. Click. Then we use from settlements data. For settlements data. Layer name. Settlements. Then we check whether the table looks okay. It's okay. If you see if you see something strange, probably you should fix encoding. For Russian symbols, we usually use UTF-8. Then we leave point coordinates as suggested, longitude and latitude. X field is usually longitude, Y field is usually latitude. Geometry, because we have coordinates as longitude and latitude. Geometry is WGS84, World Geodetic System. Then we click Add.
Okay.
Then we go to Vector, Analysis Tools, Vector menu, Analysis Tools, Count Points in Polygon, parameters, polygons, world map, and for example, the last one, population density 2020. Points, we have only one available point layer. Weight field, let's leave it blank. Class field also. Open output file after running algorithm.
Excuse me, Are we now in attributes or where? Sorry.
Sorry?
So we are in our new I know vector, and how did we make it to that menu?
Do you mean this one?
Yes,
Count
yes,
point?
yes.
Yeah. Vector.
Mm-hmm.
Analysis tools.
Mm-hmm.
Count points in Polygon.
Okay, thank you.
Also, if you do not remember which menu to use, you can type the tool name, count points in Polygon, and double click. So polygons, one of these polygons points only one layer available for this project. Just leave as suggested. Then click Run. This may take quite a long time, only 2%.
So it is now counting
number of points for each polygon.
Yeah, it's a big work.
This may take a while. So this is not the best instrument if we need just a number of polygons. Just the simple statistics on this, because I think we have around 100,000 settlements, or even more. So it's better to check this.
Excuse me.
Yep.
While we're waiting, can you please show parameters? We're now in log. Okay. Thank you.
So let's move to the slides. Our instrument is running, count points in Polygon. Not everything is very easy, very quickly can be performed. The next thing which can be used is the distance to the nearest hub, line to hub. So this instrument creates lines that join each feature of an input vector to the nearest feature in the destination layer. Imagine we have two data sources, for example, customers and retail places. For example, black points are customers. There are several of them, and red points are points of interest, or supermarkets, or museums, coffee shops, and so on. For each customer, we need to locate the nearest point of interest, and to compute the distance to nearest hub. This instrument is the right thing to use. допустим, у вас два источника данных о потребителях, первый, и о местах интереса, кафе, магазины, школы и так далее. Этот инструмент находит для каждого потребителя ближайший по расстоянию из второго слоя, из второго источника данных. Okay. Also, it's possible to perform the nearest neighbor analysis to find the mean distance for each for all the neighbors, to compare the z-score with a normal distribution, which tells you how your data are distributed. So you can even define whether your data is randomly distributed or it's or the data are clustered. For example, this is a picture on how we use data on clustered distribution, or random distribution, or dispersed distribution. We'll skip this. And the last thing to study is buffers. I think you heard about the so-called buffer zones or buffering. Buffering creates two areas. One area that is within a specific distance to selected real-world features, and the other area that is beyond. So the area that is within the specific distance is called the buffer zone. A buffer zone is used in many different fields in our life. For example, you know, some countries still use lockdown rules. In Australia, they have the 6th or the 7th lockdown now, and people cannot travel further than 10 kilometers from their homes as part of the current lockdown rules. So if this is your home, this is a point with geographical coordinates, you can travel in this buffer zone within 10 kilometers. Buffer zones in QGIS for points are shown as circles, but in fact they are not circles. They are polygons, in fact. Also, you can define buffer zones not only for points, but for lines and for polygons. For example, for two rectangles, buffer zones are in green. As I told you, buffer zones for points are not circles, and you can see the vertices of each polygon. And it's possible to define multiple buffer zones. For example, for nuclear power plants, multiple buffering zones can be used as part of an evacuation plan. have to wait. Okay. I will skip this because we need to use Qgis for this. This is an example of buffer zones applied to manufacturing plants in Russia. You probably heard about the so-called cluster initiatives, или кластерные инициативы. They defined by the ministry or by the government of Russia, and only the limited number of plants from a list prepared by the ministry can be included to the cluster initiative. Here you can see in the second picture these plants and the dashed line is a zone with natural cluster. Помимо кластерных инициатив существуют также географические кластеры, как множество предприятий, расположенных в одной местности. So informal clusters and the government-defined clusters are not the same in each region. For example, in the second picture, in Tatarstan, they coincide, but in the first picture, in Chelyabinsk region, in Sverdlovsk region, we don't have any official cluster, but only geographic cluster. And in different regions, there are different situations. We have, for example, in Permsky region, only cluster initiative, but there are no geographical clusters for this industry. So we can use this tool to analyze the spatial distribution of economic activity. For this case, spatial distribution of manufacturing plants in different countries. It's a common GIS instrument. We have 92% completed. So I think it's better to make to have a break, and after the break we can have a look at the result. Period.
So we'll continue at 1 p.m.
Yeah.
Okay. Thank you.